The Open Systems Interconnection or OSI model describes even layer that computer system use to communicate over a network. It was the first standard model for network communications adopted by all major computer and telecommunication companies in the early 1980s. OSI is a model for how applications communicate over the internet in order to facilitate interoperability between diverse devices and applications. The OSI model describes computing functions into a universal set of rules and standards. The OSI model can be thought of as a universal computer networking language. Now, I will discuss the 7 layers of the OSI model. Layer 7 of the OSI model is the application layer. Application layer is the OSI layer closest to the end user, which means that both the OSI application layer and the user interact directly with the software application. These application software are those that implement a communicating component. Applications such as web browsers that uses HTTP or HTTPS, for example, are Google Chrome, Firefox, and Internet Explorer, etc. This application uses application layer protocols. For Google Chrome, Firefox, and Internet Explorer, they uses HTTP or HTTPS. HTTP, HTTPS, FTP, NFS, FMTP, DHCP, SNMP, Telnet, IRC, and NNTP. All of these protocols form application layer. These protocols form end uses by file transfer, email, web surfing, virtual terminals, etc. For file transfer, it uses FTP. For email, it uses SMTP. For web surfing, it uses HTTP or HTTPS. And for virtual terminals, etc., it uses Telnet. Application layers provide services for network application. These softwares allows the application layer to supply data to and receive data from presentation layer. Functions of the application layer are the network virtual terminal, second is file transfer, access and management, third is addressing, and the fourth one is the mail and directory services. The network virtual terminal allows the user to connect the user system to a remote device to access functions and services. To establish remote access for the user, the application layer emulates a terminal at the remote host. The second function of the application layer is the file transfer, access, and management. Through remote accessing can transfer and manage files from the user system in a remote system. The access of files is handled in terms of file attributes such as file structures and the functions applied to the files and their features. The third function of the application layer is addressing. Addressing establishes the connection between the network devices requires the need to address. Application layer handles the request from the client to the server. This is possible by using the server and the client address. The server will reply to the client's address using the DNS service for addressing. The last function of the application layer is the mail directory and services. The application layer is also responsible for handling email, forwarding, and storage. This function of the application layer is also responsible for handling access rights for global information on multiple network services. Layer 4 of the OSI model is a transport layer. This controls the reliability of communication through segmentation, flow control, and error control. In segmentation, data received in session layer is divided into 3 small data units called segments, each segment containing port number and sequence number. Port numbers helps to direct each segment to the correct application, while sequence number helps to correct order to form a correct message for the receiver. In flow control, it controls the amount of data being transmitted. Example is the amount of data of a sender that can be transferred in Mbps and the amount of data that a receiver can receive. And the transport layer controls the data being sent and received in different devices. Error control. When data is not received, it uses automatic repeat request to retransmit the corrupted or missing data. Process-to-process delivery is one of the main tasks of the transport layer to effectively deliver the data segments to the correct destination among all working applications. This task applies a 16-bit port number to identify the sender destination applications correctly to transfer the data over the network channel. Moreover, a part of the function of the transport layer is the multiplexing and demultiplexing. Multiplexing is also one of the core tasks of the transport layer to allow simultaneous use of multiple networks over the sender side. Demultiplexing is done to the receiver side to obtain data from multiple sender applications. Also, a congestion control function. A congestion control is used to handle the network traffic of the data in the network model due to excess data being transmitted. The congestion of data is handled in two parts, the open loop control and closed loop control. The open loop control is used to stop the congestion condition in the network, while the closed loop control is applied to eradicate the congestion situation in the network. Protocols of transport layer are the UDP or User Datagram Protocol and TCP or Transport Control Protocol. These protocols uses two services, the connection-oriented transmission and the connectionless transmission. TCP uses connection-oriented transmission while the UDP uses connectionless transmission. Therefore, UDP is faster than TCP, and TCP enable us to resend lost data.
Network layer. Network layer is responsible for sending the received segments and providing them with the destination address. When the data is to be sent, the network layer accepts data from the transport layer above, and the network layer is responsible for breaking the segments into the data packets and sends it to the data link layer. This layer also ensures that the packets are transmitted through the best possible route. This layer also uses Internet Protocol version 4 or IPv4. The network layer is the critical component of the ISI model because it is responsible for facilitating communication across networks. It provides a mean for addressing encapsulation, routing, and decapsulation of data packets. The network layer has four basic processes. The first one is addressing. Addressing occurs when a device in a network wants to send a data to another device. It must be specified by the source and destination address. The second one is encapsulation. Once the source and the destination addresses are specified, the encapsulated data packet now includes all the necessary information for routing and delivery. Then this packet is handed over the data link layer for further encapsulation. The third one is routing. Routing is the process of determining the path that data packets should take from the source and to the destination. Routers are devices that operate at the network layer and make the routing decision based on the destination IP address in the packet header. The last process is decapsulation. When the packet arrives at its destination network, it goes through a process of decapsulation. The packet passes through the routers along the way, and each router removes the network layer header before forwarding the packet to the next hop. This process enables the data to traverse complex networks efficiently and reach its intended recipient.